Hi everyone, today we will clear two confusing words, hyperplane and decision boundary. Don't worry, it's actually very simple. We start from 2D, then understand 3D, and finally what distance and side mean. This is very important foundation for SVM because once you understand what the boundary is, SVM becomes much less scary. So let's go slowly and keep it visualized. First, the word hyperplane sounds big and the idea is here very small. A hyperplane is just a flat divider. In 2D, the divider is fine line. In 3D, the divider is flat sheet like a plane. So whenever you hear word hyperplane, just think a clean, flat wall that separates space. If I draw one line straight on the paper to divide two groups, am I already using a hyperplane? Yes. Let's make it more clear. Imagine two groups of dots on paper. To separate them, you naturally draw a line between them. That line is the simplest border you can create to split those. And this is called 2D hyperplane. So you already knew hyperplanes. You just didn't call them that. We here call as a straight line. If I draw a curve instead of a line, is it still a hyperplane? No. Hyperplane means flat. Now, the same line has another important name, decision boundary. Why? Because it is the place where the model's decision changes. One side of the line becomes class A, the other side becomes class B. So the decision boundary splits the whole space into two regions. If a point jumps from left side to right side, what happens? The predicted class flips. Here is very easy analogy. Think of building floor with zone A and zone B. There is a divider line. If you are standing in zone A, you follow zone A rules. If you are standing in zone B, you follow zone B rules. In machine learning, our map is not building map. Our map is feature space. Feature space simply means a world made from your input numbers. So if my features changes, does my point move on the map? Yes. Decision boundary is not just a line and sitting here there. It also has a sense of direction. Imagine an arrow pointing from the line. The arrow side can be treated as the positive side. The opposite side becomes negative side. This helps the model to stay consistent about which side is which class. That arrow has special name, normal direction. Normal means it points perpendicular to the boundary. Why is this so important? Because it tells which way the model score increases, how model is tilted. So a clean boundary is controlled by clean normal direction. Quick check. Normal is parallel to line or perpendicular. The answer is perpendicular. Now we add one more powerful idea here, distance. Not all predictions are equally confident. If a point is far away from the boundary, the model feels confident. If a point is very close to the boundary, the model is less sure. So the boundary is like border. Near the border, you can get confused. Far from border, it is very clear. Let me combine these two questions. Which side are you on? How far are you from the boundary? When we combine both, we get very useful idea. We call it signed distance. It tells us both direction, which side, and distance, how far. So signed distance is like full location answer. Not just where, but also how safely inside. If signed distance is very small, what does that mean? This means you are close to the boundary. Let's make signed distance super simple. It has two parts, a sign plus or minus, second a number, how far. If you are on one side, distance is positive. If you are on the other side, distance is negative. Now watch this point as it moves. Far inside region A, the model confidently says A. As it comes closer to the boundary, confidence reduces and prediction flips. At one exact point, the moment it crosses the decision boundary. So class changes is not random. It happens exactly at the border. Okay, here the question is, when does prediction change? Near the border or after crossing? So answer is, it changes exactly when crossing. Now let's finish with the 2D to 3D jump. In 2D, the boundary is a line. In 3D, boundary becomes a plane, a flat sheet. But the idea never changes. It's always a flat divider that splits the space into regions. So don't fear with the higher dimension. The word changes, but the picture stays the same. So here the closing statement, hyperplane is just a flat divider and decision boundary is where the class changes. Thank you for watching.